Hi, this is Simbuja. My ID is SC779 and I'm from Hatchburg. Now I'm going to explain about like hash tables and all. Then it is like video presentation too. First question here is like what are hash tables and why are they important, and also in real world scenarios. It is like hash table is nothing but it is like a data structure that stores key value pairs, like key and value, and that allows for like fast access. And we have insertion and deletion of data, that is hash table. And that importance is like efficiency, flexibility, and dynamic sizing. And we have also real world scenarios are like databases and caching compilers, routing tables and applications. Yeah, that is like real world uses and also importance. And if I want to elaborate the importance, they are fast because like insertion, deletion, and that search takes an average of big of one time. And also they are like a versatile and can store all varieties of data ranging from key to one value. And they are memory friendly and also have good time complexity with large inputs. And when it comes to real world applications include like hmm, that stores in web browsers and content delivery networks, spelling characters for directly searches for a word. And also hash tables are foundational structures that can be used in computer science, applied in several technologies that we daily apply in several technologies. And also they are important in situations in only fast and efficient access of data is more required. Yeah, that is what the first question is. And when comes to the second question, they asked about explain DAT and also like its limitations over hash tables. Yeah. When it comes to DAT, that is like direct access table, that is nothing but it's also like simple data structures where like the indices of the array is equal to the keys that allows big O of one access time. And also like you asked about limitations. Limitations are like integer keys, yeah, collision scalability that comes into the picture. Significant limitations are comparing with the hash tables. Like DTA can only use with integers key, but hash tables can process all types of keys. The unfortunate like truth about this is like it's memory insufficient for spare data or large key ranges. It is also rigid in implementation, has poor scalability feature. So in contrast, like hash tables are like more versatile. That is like keys, they are more efficient, like they can resolve collisions, the type of risk with all the different types, and maintaining this like high performance over large memories, like under advantage. Uh, yeah, this is what. And when comes to the this third question is like they asked about what are the collisions and explain about linear probing and quadratic probing. Collision is like nothing but when two different keys hash to the same index in the hash table. If suppose we have a hash table, we want to put one key in certain place, but if two keys come to the same place, then the collision occurs. So we can solve this by like we have linear probing and quadratic probing. Linear probing is like when a like collision occurs with like if one key is placed in the second index and if the another key is also come to the same place, then the collision occurred. So this will checks for the if next index is like it is free or not, then it will be in the next index. Yeah, that's how it works. Suppose if I want to show with the example, if I have keys like 12, 22, and 32, I'm like my like size of the table is 10. So I'm dividing 12 by 10, so 2. So 12 goes to the second index. And this is like 0, 1, 2, so it goes to the second index. And when I'm inserting 22, it will like the hash table size is 10, so I divided by with 2. I mean divided by 10, so I got 2. So now 12 and 22 goes to the same index. So here collision occurred. So Now for 22, I will check with the next index. So this is 2. So this index plus 1. So this is empty. I check this is empty. So I placed it here. And next, whenever I am checking with the next number is 32. So that also comes to the same index. So now I want to place it here actually. But there is already, it is filled. So I will go to the next index and check. This is also there. So next index I will go and check, that is like empty. So I place 32 here. That is what linear probing is like. Yeah, that is what. And when it comes to the quadratic probing, it is like when a collision occurs, it checks slots at quadratic intervals from the original hash index. So here example, if we see, yeah, here also same 12, 22, and 32, and the hash table size is 10. So when 12 is divided by 10, we get 2. So here we are placing 12 at second index. That is fine. So next when we check 22, and it's also getting the same index. So in linear topic, we just check it the next index is empty or not. If empty, we place it. But here like we will check this index plus next one. So 1 square I am doing. So 1 square is like 1, 2 plus 1, 3. So it comes to the third index. So I place it here. So when comes to 32, this is also coming to the second index. So I will do the same process like 2 plus. So I will search for the next one plus 1 square. It comes to 3. But in third index again other one is placed. So next again I will do with 2. So 2, this is actually 2, second place, right? So 2 plus 2 whole square, then it comes like a 6. So I place 32 in the 6th place. Yeah, actually that is what quadratic probing is. Like both probics are the same, but like when so both has their advantages and disadvantages. It is like it is easy and more efficient. Like linear probing is easy and more efficient because we directly checks the next one. When comes to this quadratic probing, it is little bit like we need to calculate and check for that. Yeah, so both are have advantages and disadvantages. Yeah, thank you. This is my explanation about hash tables.